After decades of research, construction, and a Christmas Day launch, we are getting more full-color images from the James Webb Space Telescope. Mark Strassman has a look at the birth of the universe.
James Webb Telescope just made a terrifying discovery that just shocked the entire world, revealing patterns of cosmic behavior that defy everything scientists believe to be possible. Observations initiated as routine deep-field scans suddenly flagged a region of space exhibiting a spectral signature unlike any seen before. Initially, the data appeared as anomalies, subtle irregularities in the infrared light that the telescope captures so precisely. Those anomalies, however, quickly intensified, leading researchers to realize they were witnessing an event far more significant than a mere blip on the screen. A sense of mounting dread spread through the community as the implications became clearer. Something vast and unseen was on a trajectory that could alter humanity's understanding of the universe itself. The moment that realization set in, it dawned on observers that this was not just another textbook discovery, but a harbinger of an existential question no one had yet considered in private. The very fabric of cosmic order seemed unsettled, and the world held its breath as the full magnitude of the finding emerged. Before we start, hit the like and subscribe buttons for more exclusive news. At first, experts believed the irregular signatures to be the result of instrumental noise or a calibration error. After all, the James Webb had been through rigorous tests to verify its sensitivity and accuracy. Yet as the data poured in night after night, the same unmistakable pattern persisted. The anomaly manifested as a faint but coherent distortion within the background radiation of a distant stellar nursery, a region already known for its intense star formation activity. What terrified astronomers was not simply that something was happening there, but rather what that something appeared to be. A massive, rapidly expanding void, consuming light and matter at a rate that defied conventional astrophysical models. Such a phenomenon, if genuine, would rewrite the rules of gravitational physics and challenge the notion that the universe's expansion should be uniform and predictable. Researchers across the globe began to scramble, poring over archived data from earlier missions to see if any hints of this phenomenon had been missed. As data validation progressed, it became impossible to deny the reality of the void's existence. The region in question lay in a galaxy cluster approximately 13 billion light-years away, placing the event at a time when the universe was still in its infancy. That realization alone was enough to send ripples of unease through the scientific community. To think that such a structure could form so early challenged theories about how matter coalesced under gravity. Traditional models suggested that galaxy clusters developed over billions of years, gradually pulling in gas and dark matter to build the scaffolding for star formation. This void, however, seemed to represent an anti-structure, a black hole of a scale never before encountered, swallowing light in multiple wavelengths and warping space-time to the extent that even the James Webb's infrared instruments could not penetrate its depths. The more scientists delved into the spectral readings, the more it became clear that this was not a natural byproduct of star formation or galactic collision. It was something entirely new. The confirmation of the void's presence marked a turning point. International teams of astrophysicists and cosmologists convened emergency virtual meetings, sharing data at unprecedented speeds. Simulations were run on every supercomputer available, yet none could replicate a phenomenon that matched what the telescope was showing. The expanding void exhibited behavior inconsistent with a singularity or a conventional black hole. Instead, it appeared to consume energy in all directions, growing in size at a fraction of the speed of light. As it expanded, it began to affect nearby galactic structures, bending light paths and distorting the cosmic microwave background in measurable ways. For a brief moment, it was as if a colossal cosmic saw had been unleashed, carving through the tapestry of space and time. The potential implications were staggering. If this void continued to grow unchecked, it could eventually converge with other structures in the observable universe, possibly leading to a cascade of events that no existing theory could predict. Initially, there was hope that the void might stabilize or dissipate, much like other transient cosmic phenomena. Supernova remnants, for instance, often expand rapidly before cooling and fading away. But repeated observations showed the void's growth was sustained. Early hypotheses posited that an exotic form of dark energy could be fueling its expansion, but the rate of growth far exceeded any dark energy models known. Another proposal suggested that this might be the result of a collision between parallel dimensions, with the void representing an interdimensional rift. While that idea bordered on science fiction, the data continued to confound conventional wisdom. Instruments detected fluctuations in the local gravitational field that did not correspond to any known forms of matter or energy. The void appeared to possess its own localized space-time curvature, independent of surrounding mass distributions. In effect, it was bending its own region of space inward, creating a self-sustaining vortex that defied explanation. Public announcements followed once the scientific consensus confirmed that the void was both real and significant. Images released to the media showed the distorted backdrop of stars and galaxies, warped by the void's gravitational influence. Even lay people could sense the enormity of the discovery by examining the warped light patterns, which conveyed a sense of profound emptiness at the heart of the region. News outlets around the world ran headlines warning of an unprecedented cosmic threat, though no immediate danger to Earth was identified. Still, the notion that the universe could harbor such unpredictable forces unsettled many. Philosophers, theologians, and artists joined the conversation, pondering humanity's place in a cosmos that could conceal malevolent phenomena. Social media buzzed with speculation, some granting credence to panic-inducing scenarios, while others emphasized the scientific imperative to study the void calmly. Regardless of the tone, this discovery shifted public consciousness, prompting renewed interest in astronomy and a shared sense of vulnerability. As weeks turned into months, research teams focused on gauging the void's trajectory and rate of expansion. By triangulating data from the James Webb Telescope with readings from other observatories, scientists constructed a three-dimensional map of the affected region. The void's shape resembled a twisted hourglass, with filaments of distorted light stretching outwards before curving back in, like sine waves suspended in space. These filaments suggested that the void was not uniform. Rather, it contained pockets of fluctuating intensity where gravitational anomalies peaked. In these hotspots, even light itself seemed to slow down, taking longer to escape than in surrounding areas. Such behavior implied that time itself was being dilated within the void's boundaries, raising profound questions about the nature of temporal flow under extreme gravitational conditions. Some theorists speculated that time inside the void might be nearly frozen, effectively isolating that region from the rest of the universe. The existence of such temporal distortion had dramatic implications for understanding causality and the conservation of information. If time were effectively stalled within the void, events there could be preserved indefinitely, creating a cosmic archive frozen in the moment of discovery. However, because the void was actively drawing in energy and matter, any new information entering its boundaries would become inaccessible to the outside universe. That led to a paradox. Was the information truly lost, or simply delayed? Traditional interpretations of black holes posited that information might be preserved on the event horizon, but this void displayed no discernible horizon. Instead, it seemed to possess an interior boundary accessible only by extrapolating complex gravitational equations. The challenge then became to determine whether this entity conformed to the laws of quantum mechanics or represented a novel class of object altogether. If quantum rules failed within the void, physicists would need to propose entirely new frameworks to accommodate its behavior. Amid these theoretical debates, engineers began recalibrating the James Webb's instruments to conduct deeper spectral analyses. Specialized filters were employed to isolate faint signals that might hint at the void's internal composition. Early hypotheses suggested that it could be a concentration of hypothetical particles, perhaps a region where dark matter density spiked to unprecedented levels. Yet the refined spectra did not match any dark matter signatures theorized to date. Instead, researchers detected a peculiar oscillation pattern in the incoming photons, hinting at interactions with unknown fields. Some scientists entertained the possibility that this void could be a manifestation of a collapsed higher dimensional structure, a relic from the universe's earliest moments when extra dimensions might have briefly influenced cosmic evolution. If so, studying these oscillations could unlock secrets about the very nature of spacetime beyond the familiar three spatial dimensions. Such a revelation would revolutionize physics in a way comparable to the discovery of general relativity a century earlier. If you liked this video, please give it a like and subscribe to our channel. Also, could you leave your comments below and tell us, what are your thoughts on James Webb's terrifying discovery? What do you think it means? We want to hear from you. Thank you for watching, and see you next time.